Hello, everybody, and welcome to VMworld 2021. My name is Phil Kippen, and I lead our solutions and field engineering team for VMware. I've got also Daniel Erb with me. Daniel is the Vice President of Product Management for Vapor.io. And we're going to talk about transforming the industry from the edge out. Pretty interesting topic. We've got some pretty cool stuff that we're working on that we want to share with you. But first, take a look at this disclaimer. I know we're going to be talking about stuff today that we don't have released, stuff that we're working on, and even some stuff that we're just thinking about. So we'll make some of that clear as we move through the presentation, but make sure you read the disclaimer entirely. All right, so Daniel, let's talk about Industry 4.0. So when we think about enterprises and we think about Industry 4.0, we think about enterprises that are focused on production automation, control and monitoring, optimizing those processes, and then certainly with respect to all of those things that enterprises are using to do that, we've got sensors and application, telemetry, analytics, data management. When we think about the cloud, right, especially for Industry 4.0 and bringing all these capabilities together for the enterprise, we're thinking about multi-network and multi-cloud, and then certainly the tightness between those two, right? There's a lot of synergy between both of them. And certainly if we're going to make Industry 4.0 real for our customers, whether it's service providers or enterprises, we need to focus on ensuring that multi-network and multi-cloud operate together ubiquitously. So when we think about the interesting use cases and certainly the diversity of requirements, what do you think of, Daniel? What's the first few thoughts that come to your head?
Yeah, let's talk about some use cases. So if we think about the construct that you just described, the automation, the optimization, what are some examples of that? One of the things that I would highlight is that if you look across industries, we've got some very kind of typical example use cases here. Some of them more forward-leaning, like autonomous vehicle. Many of them, what I would call more standard in terms of things that people have been working on for quite some time. The one thing that stands out is that it's really a heat map of different needs. So even in this small representative set, you can tell from looking at the different requirements, the darker colors indicating more critical, the lighter colors indicating just a nice to have. There's very little similarity between them. There's a very wide range, and that distribution actually just grows broader the further you go in any industry. So one of the things that is most typical about this whole adoption phase is that what is being served has a really broad and diverse set of requirements.
I think the most diverse that we've seen in years, right, if not ever. I know when we talk to enterprise customers, we have customers that are looking at multiple use cases on this slide. And so certainly it's not just one or the other. It's customers who, just to enable Industry 4.0 across their enterprise, are looking at multiple use cases that have completely different requirements. So absolutely, it's a pretty unique time and certainly a pretty exciting time if you're an enterprise or a service provider here as we move into 5G. All right, so I think Daniel, you and I have talked a lot about this, and this is our position. The internet that we need is not the internet we built. Daniel, kick it off for us here.
Yeah, there's a catch. So we have these emergent use cases. We have really aggressive adoption across all different spectrum. However, there are real challenges. And as you said, we really like to highlight the fact that the internet that we need is not how the internet was envisioned. It's not the way that the organic growth and the evolution over time has created a fabric that can serve these things. So if we think about the fact that, as I mentioned, very diverse, and as you mentioned, we can go to any one of the customers that we're working with today, they'll have a ladder of things that they want to do. So the number of applications, the breadth of the sensors that are pulling and exposing data, increasing exponentially. And so that scale and that intensity is not something that, from a protocol level up, the networks that we're working with today were not built to serve that. That's one of the whole purposes of the creation of 5G and the rollout of 5G, was to begin to address some of these foundational problems. Similarly, the underpinnings of how even 5G and other networks work, they're built to be served from a very core-centric premise. But most of the use cases we're talking about begin at the premise, at the edge. So there's obviously a continuum, but it remains a real challenge that we are trying to serve this diverse need of edge use cases with a centralized core behind most of the compute, the network, and the other infrastructure that sits behind it. And then lastly, I'd call out the whole idea that we've got what sometimes in the land of IoT gets referred to as the three laws, right? The laws of physics, the laws of governance, and the laws of economics. The need for proximity, for real time, and for data provenance. Those needs, again, very driven by what happens in localized and contained areas at the edge, poorly served all the way from the core. So there's got to be some way to bridge the fact that most of these requirements are rooted in needs that are diverse and live out at the edge of the networks, but must be served from the centralized core.
Absolutely. And I think if you believe in 5G, right, you believe in not just hundreds of thousands of applications, you believe in millions of applications. And if all those applications are sitting at the edge, generating data, right, that's being analyzed for the purpose of these services, there's a massive weight of data out there at the edge. And certainly the ability to keep that data close, with respect to a service provider looking at an enterprise customer, the ability for the service provider to keep that data as close as they can to the enterprise has benefits in terms of certainly the cost structures that service providers need to maintain, but also for the enterprise, it allows them to offload some of that equipment, certainly those applications from their enterprise prem up to the service provider prem. As long as that proximity is within the latency requirements, then they're good to go, right? That service can exist either on enterprise prem or on the service provider prem. Really a very interesting problem. And we definitely, when we look across service providers and enterprises, we definitely don't see that things are really built today the way that we need them built, and the internet that we need is definitely not the internet that was built. All right, so we've got a pretty interesting solution here. This is where things get really cool. Our multi-cloud services grid is made up of a number of components, essentially components from both VMware and also Vapor.io, and we're going to talk about each of those in a second. But coming together to really solve for some of those challenges, specifically the three challenges that we saw previously: the ability to host millions of applications, certainly the ability to demarc or to anchor data at the edge where it belongs and let it move east and west, as opposed to north, south, east, and west. And then as well, as we start to look at, for instance, the proximity aspect of it, Vapor's data center and data center architecture, and also the kinetic grid specifically, and how that works, really puts that data and puts those applications extremely close to the enterprise. So Daniel, why don't you talk a little bit about some of the components we have here and their benefit, their value?
Yeah, let's do that. And so just as you mentioned, this is why it's been so fun and exciting to be able to work on this with VMware, because what we're seeing here is, again, if you think about the challenge we spoke about a moment ago, obviously we're not going to leave behind the internet that we have today. Everything that we have today, the problem is that we need more of it. So what we need to find amongst ourselves is, how can we really unlock and unleash the capabilities that we currently have by adding more to that mix? And in this case, the more is what we think of as the middle mile, or infrastructure that sits between the centralized internet of today and the last mile networks. So that infrastructure has to exist, in our view, as a single platform. And as you mentioned, from an economic standpoint, really makes most sense as a neutral host platform, which means that it's shared infrastructure that many people can use, as opposed to vertically. If you think about all these different use cases, if we're building infrastructure to serve each use case, that's obviously a crippling overhead and really inhibiting the growth. Whereas if we can have an infrastructure that is built from the beginning to be distributed, to be interconnected, and probably most importantly, to be instrumented. So to have real-time data explodes in a homogeneous fashion that is flowing off of it, that's the real game changer here. And so the piece that Vapor brings is to take that infrastructure really from the dirt up. So the fiber, the data centers, and really make sure that that exists as a platform that can be fungible to the providers on it. That's where you see here we have the examples of some of the leading compute providers, AWS, some of the bare metal providers doing some really innovative things in the market. some of the OEM giants such as Dell, who are really moving into the game in a very integrated manner. All of those providers now have a way to get placed so that they are no longer locked into this dichotomy of the expensive vertical overhead of being on-premise or some of the latency and routing restrictions that come if you're back in a centralized core. And Sense is that you see on here is the open source software that we use that is the telemetry stream that can open all of this up to make it orchestratable. And of course, that's where VMware comes in.
Absolutely. So I think it's extremely convenient for an enterprise to have access to multiple public cloud providers in the same data center, in the same, for instance, Vapor facility. If they can choose between AWS, Azure, Google, or just let traffic essentially get optimized for fast path offload, they're able to hit those public cloud infrastructures much faster, certainly with fewer hops. And that obviously reduces the amount of delay or end-to-end service backhaul that would have to be done. So you talked a little bit about Sense. Now, I think Sense is extremely cool. We talked about the telemetry. At least you mentioned the telemetry. We just finished a demo, as you know. We'd love to show it to everybody. Unfortunately, it was a little bit too long for this session, but reach out to your VMware contact and they can get you the demo or schedule some time where we can get on and we can demonstrate what we've built. But essentially, with Sense, we've been able to take the data stream from Sense that is polling essentially for environmentals and backup power and other things within the data center. We can take that data stream in, recognize that there's a power failure on a host, and that we have 7 minutes, for instance, of backup power before that host disappears and goes offline. Our orchestrator within our telco cloud platform will listen for that data or those alerts, take those alerts, and then send a command to our orchestrator that essentially says, go ahead and decommission that host, take those applications and spin them up on a different host in a different availability zone, and then fully decommission the host and expect the power to completely go away at some point in time, right? As that 7 minutes is ticking down. So if you think about the interlock between Vapor's platform and the data centers, the physical proximity, the ability to do all of this, optimized offload, and then also the ability to really pull telemetry from even literally the bottom of the architecture itself. I think it's pretty interesting. It's very cool. And we had a great time building this demo. And I think it shows something that, that nobody's been able to show before. It really shows that multi-cloud platform, managing that multi-cloud infrastructure across those multi-cloud or neutral host data centers. Very cool stuff. All right, so let's look at it from an architectural perspective. Let's make this all real. We talked about the VMware Telco Cloud Platform. We talked about Vapor data centers. We talked about Sense, as a data stream for providing telemetry up to the higher layers, service and orchestration platforms. What does this look like from an architecture?
One of the things that we've really come to adopt as we thought about what this looks like from an architecture is the idea that, again, there's a physical place that this needs to happen. And so we've started calling this, along with our partners, it's a name that we've co-developed with some of the leaders in this field. We call them industrial zones. Sometimes we shorten it to an in zone. But the idea that an industrial zone, as if you think at the beginning of this presentation, those Industry 4.0 use cases, is talking about Industry 4.0 in the specific physical locations that require this densification of infrastructure. What you're seeing here is the idea represented in the hexagons that you've got resilient infrastructure that is interconnected by dedicated fiber. So you've got unique routes, you've got resilient routes, you've got the little autonomous data centers that are allowing you to place compute, what we call near-prem, right near the premise instead of on-premise. All the benefits now of centralized cloud that we talked about, hauled down to the edge of the service provider network so that they are right next to enterprise that need it. And this is how we talk about solving that sort of intractable problem of really needing to fix the internet that was with a better version of it.
Absolutely. I know we've been working closely on time-sensitive fabrics and really the ability to optimize the path that data needs to flow, either between service functions or to a public cloud facility. So whether it's going, for instance, to the RAN or whether it's going to a Vapor data center, it could be, a wireless connection that a 5G, for instance, private connectivity service that an enterprise is connecting up with the service provider edge in the RAN, or it could be a terrestrial link that's connected directly to Vapor's micro data centers. The time-sensitive fabric will actually work to optimize that connectivity and ensure that not only is that traffic, traversing through the fewest number of points, right, and removing as much congestion as possible, but that when a service is configured, that each component in that service can meet the service SLAs. So that time-sensitive fabric is critical. If you're bringing multi-clouds together or multiple clouds together, you're bringing together public cloud, let's say service provider private cloud, and enterprise private cloud. You're bringing all three of those together. You need a predictable way to connect them. And that's what we meant initially, right? When we were talking about the interconnect between multi-network and multi-cloud, right? You really need the network and the cloud to be working together. And I think, based on what we've been able to do, we're starting to see more and more unique use cases coming from the capabilities of this new intelligent edge, and specifically this time-sensitive fabric. All right, so go ahead. What were you going to say, Daniel?
I was just going to highlight that much as you were calling out the use case that we built as a demo, one of the things that has really gotten unlocked here is you see Telco Cloud Assurance really kind of automating the SLA is one way to think about it. This is no longer human scale, manually configured. This is composable on the fly, and the IT workload is now prioritized where it needs to be. So instead of kind of a fixed monument that you have to throw capital and densify and harden it, there's a much more resilient way to scale. And I really like to think about the fact that this moves from a capital intensive to more of an OpEx model, which is one of the principles that really has brought all of us to adopting cloud as a fundamental way of doing business. I think we see some of the same motion here that, Phil, just as you highlighted, it's really by unlocking the combination of hybrid network, hybrid cloud. If you don't have multi-cloud, multi-network, you can't get it done. And so to bring them both together in this stack, I think is super powerful.
Absolutely. I think the optimization capabilities that we've both been working on have been, I would say, have taken things to certainly a next level. Not only are we able to optimize that path, but also where we place those applications, make sure that the service provider is using their infrastructure most efficiently, and then also that the enterprise has an available service that meets their SLAs every single time because of the infrastructure, the fabric, all of the things that come together to make up this solution. So outstanding. So we've got a solution for it. We outlined the problem. Let's recap on the value proposition here, and we'll let everybody go and take a look at all the cool stuff that we've been able to build in our demo kit. But before we do, enterprises. Daniel, what is the benefit to enterprises here with the solution?
Yeah, so again, let's think back to the beginning. The benefit to enterprises is they get the economy and the performance that they're used to from cloud and centralized compute to solve that rich and diverse mix of use cases that we saw up front, but no longer having to trade off the security and the control of running this from on-premise. It's a true optimization to try and capture the best of both of those worlds for the enterprise.
And for service providers, definitely the 5G services, and specifically the new services that this solution, this new architecture and its capabilities enable, are things that service providers couldn't do today without it. The advanced telemetry really leading to higher availability, but also giving us the ability to optimize and where we place applications, and certainly where we move data from, more efficiently utilizing that architecture, localizing that traffic at the edge, which is super important because we don't want to be sending it all the way up to the core to traverse across a peering point, coming back down to the edge. That doesn't make a lot of sense. As we start to move forward with this architecture and certainly this solution, and we release it, we're going to start to look at federating across the edge. So now we have east-west traffic, and we have a much more latency sensitive fabric that we can work with across service providers. And then certainly the rapid time to service deployment. Being able to deploy in a Vapor data center, it's easy, it's fast, right, Daniel? How long does it take to get a service up in a Vapor data center? We've got all the equipment in there, the service provider is ready to turn it up. for the enterprise, how long does it take to actually get that service provisioned?
That's an exciting story for us, right? That can be turned up in, depending on the fabric that we have installed with VMware, that's happening below the scale of human perception. So think of us as being active. And as you mentioned, Phil, your availability zone, if you want to think about it that way, can be down inside urban neighborhoods, can be across city scale, can be across cities in the US.
Absolutely. So very fast. It's just a matter of automated configuration. Literally on our platform, we can deploy that service in a matter of minutes. And all that time-sensitive fabric and optimization capabilities that we've talked about are all being utilized as we turn that service up. So super fast time to service deployment, certainly by the benefit of Vapor and their data centers and all the great telemetry that we get from those data centers. We're really able to change the game for service providers looking to provision those ultra-high reliability and low latency services like Industry 4.0 and things like factory automation, autonomous vehicles, and those types of services from the service provider edge. All right, Daniel, so I think we've covered just about every single slide and certainly every single point that we wanted to get out there. I would highly encourage anyone who's interested in taking a look at our demonstration and seeing what we can do. Let us know. We're more than happy to show you. And we appreciate all your time today. Please take your survey, and then certainly thank you for your time today. We certainly enjoyed it, and I know Daniel and I did.
Thank you so much.
Take care, everybody.